In this video, we're going to discuss how to add and subtract rational expressions. Remember that rational expressions are just fractions that contain polynomials. And you guys learned how to add and subtract fractions like these in elementary school, but it's been a long time perhaps since you had to do it without a calculator. So remember that in order to add or subtract fractions, we need something called a common denominator. One of the easiest ways to find a common denominator is to multiply the denominators together. And since these two denominators, 3 and 5, do not have any common factors, that's going to also be our least common denominator. So 3 times 5 is 15. But I can't just multiply the denominator by a number. I also have to multiply the numerator by the same number. So what did I have to multiply 3 by in order to get 15? The answer is 5. So I'm going to multiply the numerator by 5 as well to get 10. And what did I have to multiply the 5 by to get 15? Had to multiply it by 3. So I'm going to multiply the numerator, the 4, by 3 as well, and I get 12. So the other thing that you need to remember is that when you add or subtract fractions, the common denominator stays common in the solution as well. And we only add the numerators. So we get 22 divided by 15. Sometimes you can simplify your sum, but in this case, because the numerator and denominator do not share any common factors, our final answer is 22/15. Now, keeping that in mind, let's follow these 4 steps to add and subtract the rational expressions that you see on this notes sheet. First of all, we're going to factor to find the LCD, or least common denominator. In this first problem, you'll notice that there's nothing we can factor in the numerators or denominators, but you'll also notice that the denominator already is common. So we won't need to do anything to be able to add these together. And when we add them together, the common denominator is going to stay the same all the way throughout. So now we're already on step 3, which is to combine the tops, or the numerators. And when we do that, we're just going to combine like terms. In the numerator, here we have a 2x and a 3, and here we have a 3x minus 1. The like terms are 2x and 3x, giving us a 5x when I add them, and 3 and negative 1, giving us a 2 when we add them. So our final answer for this problem is 5x plus 2 divided by 4x. And notice that we can't simplify this because we do not have any common factors in the numerator and the denominator. Let's try one that's a little bit more challenging. In the second problem, we do not have common denominators. But you'll notice that the factors of this denominator are 8 and x. And the factors of the second fraction's denominator are just an x. So in order for them to be common denominators, we're going to need to multiply the denominator and the numerator of this fraction by 8, which will leave the first fraction alone, 3 divided by 8x, but make the second fraction an 8 divided by 8x. So we have 3 over 8x minus 8 over 8x. We're going to keep the denominator the same throughout, and in this problem we're just going to subtract the numerators, and 3 minus 8 is negative 5. There's nothing we can simplify because 5 is not divisible by 8 and they have no common factors. So that's how we do the second one. Now in the third one, we have binomials. We have a 3x plus 5 and we have an x plus 7. Now the first step says to factor, but there's no way to factor either of those two binomials. So what we're going to have to do instead is we're going to have to find a least common denominator like we did in our original problem at the top. And the only way we could find a common denominator there was to multiply the two denominators together. So my common denominator is going to be 3x plus 5 times x plus 7. But in order to get that denominator in both of the original fractions, I'm going to have to multiply the numerator and denominator of this fraction by an x plus 7, because that's what it was missing. It already had the 3x plus 5. So I'm going to multiply this one by an x plus 7 as well. And in the other one, since this one's missing the 3x plus 5, I'm going to have to multiply the numerator and the denominator of this one by a 3x plus 5. Now, when I do that, in the first one, I'm going to have 2x squared plus 14x in the numerator in blue. And in the second one, I'm going to have a minus 15x minus 25. Now, why are both of those negative? Well, that's because I had this minus sign in front of the second fraction. So I'm going to distribute a negative 5 instead of a positive 5. And that's where I get those two parts from. Now, I already know what my denominator is going to be. It's going to be this that I wrote earlier. So all I have to do at this point is combine my like terms. I don't have any other x squared terms, so I'm going to have a 2x squared. And I do have two linear terms. So that's going to give me a minus x. And I only have this one constant term. So minus 25. Now, I could try to factor this quadratic that I have on top, the 2x squared minus x minus 25. But if you think about the factors for negative 50, none of them will add together to give us a negative 1. So I can't factor that, which means I can't simplify it, which means that this is going to be my final answer for this problem. In the next problem, you'll notice that we do have a degree greater than 1, so we can factor the denominator in this first fraction. And because this is a difference of squares, we're going to have x plus 2 and x minus 2 as our two factors for that denominator. In the numerator, there's no squared, so there's no way to factor the numerator. Now in the second fraction, there is also a degree of 1, so we can't factor either the numerator or the denominator there. Now, this first fraction has two factors in its denominator, but the second fraction only has one, and you'll probably notice that it matches one of the two factors in the other denominator. So we are only missing the x plus 2 in this denominator, which means I can multiply the numerator and denominator by x plus 2 so that I have a common denominator of x plus 2 and x minus 2. Now I need to distribute and combine like terms. When I distribute, I have a negative 3 that I'm multiplying times the x and times the 2. So that's going to give me a minus 3x minus 6. And when I look for like terms, I see I have a 4x and a minus 3x. That combined to give me 1x, and then I have a positive 1 and a minus 6 that combined to give me negative 5. And so my final answer, because there's no simplification that I can do in this problem, is x minus 5 divided by x plus 2 times x minus 2. And in this last problem, if we factor the denominator, we have an x plus 3 times x plus 2, because 2 times 3 multiplies to give us 6 and adds to give us a 5 in the denominator with an x in the numerator. And in the second one, we have the minus sign still, and an x plus 2 and an x plus 1. Now you will notice that we do have one factor in common, but we're missing two other factors. So this one also has an x plus 3, which means we need to multiply this denominator by x plus 3 and also its numerator, which I forgot to write down. That's that 2 from up top. And this denominator has an x plus 1, which this one is missing. So I'm going to need to multiply the numerator and denominator by x plus 1 here. Now, when I distribute, in the first numerator, I'm going to get an x squared plus x. And when I distribute in the second denominator, I'm going to distribute a minus 2 to the x and the 3, which gives me negative 2x minus 6. And remember, my denominator is all of those factors multiplied together. So I have an x plus 1, an x plus 2, and an x plus 3. Now, if you look at the numerator once more, we need to combine some like terms. And the only like terms I see are the x and the minus 2x. And if I combine those, I'm going to get a minus 1x. So, I have x squared minus x minus 6. Now, can you think of a way to factor that? If you think for a second, I can multiply a 3 and a 2, or I should say a negative 3, and a positive 2 together to get a negative 6, and those will also add to give me a negative 1. So I could factor my numerator like that, and my denominator is still factored like this. If you remember from our simplifying lesson, if you have the same factor in the numerator and the denominator, then you can simplify the fraction. So I can simplify this to x minus 3 divided by x plus 1 times x plus 3. Now you won't always have situations where you can simplify the final answer, but this is one where you can. So don't forget to factor the top and cancel out any factors that are above and below in the answer. For our next problem, it looks a little bit confusing because you'll notice that the first problem doesn't appear to be a fraction. But remember, you can make anything into a fraction by dividing it by 1. And these are pretty easy to work with because if we want a common factor, we can just multiply by the x squared plus 5 that's in the denominator of the fraction we had originally. So I'm going to multiply by x squared plus 5 in the numerator and the denominator of the first term. And I'm going to keep the 1 over x squared plus 5 in my second term. Then I'm going to distribute the 3. So I get 3x squared plus 15, and I'm going to go ahead and subtract the 1 and keep the common denominator. So the final thing we're going to do is combine like terms. Notice that the 15 and the minus 1 are like terms. So when I combine those, I get 3x squared plus 14 divided by x squared plus 5. Now, some people like to cancel out or think that they can cancel out the x squared, but remember, we can only cancel out factors or things that are multiplied together. And I know that the 3 and the x squared are multiplied together, but we need to have entire things that are multiplied together. And the 3x squared is added to 14, so that's considered a factor in this problem, and we cannot simplify it. In the next one, the same idea works. See if you can figure out how to do that one. So once again, you can make any number into a fraction by dividing it by 1, and the common denominator was the 3x minus 1. So I multiplied the top and the bottom by that, and I ended up with 3x minus 1 divided by 3x minus 1. Then I looked for common terms or like terms and combined those, and there's no way to simplify this one, so I'm done with it. In the next two, we need to factor, find common denominators, and then simplify. Now for this one, notice that one of the fractions when I factored it had an x plus 2, the other one had an x plus 2, and it was already factored, but this one has an additional x plus 2. And in order for these to be like common denominators, I have to multiply this second fraction, top and bottom, by x plus 2 as well. So when I distribute that 2, and it's a positive 2, when I distribute that to the x and the 2, I get a plus 2x plus 4. And now I'm going to look for my like terms. I've got an x and a 2x, which gives me 3 x's. And I also have a positive 2 and a positive 4, which gives me a positive 6. And in the denominator, I still have the x plus 2 times x plus 2. Now, don't forget to check and see if you can factor. I don't see any squared terms here, but I do see a GCF in the numerator. And if I factor out the x or the 3, I'm left with an x plus 2 in the numerator times a 3, and in the denominator I have an x plus 2 times x plus 2, or x plus 2 squared. But since I have this same factor in the numerator and denominator, I can simplify this to be just a 3 divided by x plus 2. Now let's simplify this next one by factoring and then finding a common denominator. Now I've factored, but I don't see any common factors in either denominator. That means that all of this needs to be multiplied times this, and all of this needs to be multiplied times this. Now, I either have to multiply all that back together again, or remember that all of this underlined in green is equal to this right here. So I just need to multiply that times 3. And all of this in orange is equal to this. So I need to multiply all this times the 2 over there. And here's what that gives me. So I multiplied all of the orange times 2 and got 2x squared minus 2x minus 12. And I multiplied all of the green times 3 and got x squared plus 6x plus 5. Or I'm sorry, 3x squared plus 18x plus 15. Now I just need to look for some like terms, and I'm going to have to get creative about my space since I'm almost out here. And this is what I get when I combine those like terms. Believe it or not, I can factor this polynomial because when I multiply the beginning and the end, I get 15, and the two numbers that multiply to give us 15 and add to give us 16 are 15 and 1. So this can be factored to equal 5x plus 1 times x plus 3. But remember that denominator we had from a long time ago? It doesn't have any common terms with that. So my final answer for this one is 5x plus 1 times x plus 3 divided by x minus 3 times x plus 2 times x plus 5 times x plus 1, and it cannot be simplified. Now for these last two, it doesn't look like I'm going to find any GCFs, so I'm just going to have to multiply the two denominators together to find a common denominator. So I'm going to work those out, and you can check your work. So in both of these, my common denominator had to be a product of the two denominators. In the first one, I did find a GCF, but that wasn't helpful at all. So you could keep the GCF factored out, or you could put it back in. When I multiplied, I put it back in because that was easier to distribute to the 4 over here. But that's just one option. You can distribute it and then also distribute the 2 back if you want to. So we have two possible answers for the first one, and you can choose which way you prefer to write it. In the second one, we ended up having to multiply a binomial times a binomial using FOIL or the box method, and I got 4 terms, but then I had to combine them with the two terms that I had over here. That gave me 30x squared plus 17x minus 2, and I can actually factor that. But notice that none of the factors cancel out in the numerator and denominator anyways. So even though you should always check to see if you can factor, sometimes it's not going to be helpful.